Hello, everyone, and thank you for attending the Day 2 Optical Network and Data Center Connect Digital Symposium. Thank you to our Platinum sponsors, ADVA, Infinera, and Huawei, and to our Gold sponsors, Acacia, CIG, and Viavi. Before we begin, I wanted to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget, as well as other resources made available from our sponsors. Towards the end of today's presentation, we'll ask you for your feedback. A survey will pop open on your screen and will only take a minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Principal Analyst, Sterling Perrin. Sterling?
Thanks, Reagan. Hi and hello. Welcome, everybody. Good morning, good afternoon to folks in Europe. Welcome to Optical Network and Data Center Interconnect Digital Symposium Day 2. Some of you may have been lucky enough to join the Day 1 program. If so, I'm sure you agree there was a lot of great content there on the future of optical networks. If not, today's a new day. We have new content, actually 2 tracks. Two sessions for today's event, and throughout the course of both of them, I'll be the host and moderator for the sessions. I'm of course with Heavy Reading, and I've been focusing on the optical market for a couple decades at this point. So certainly been following the content that we are looking at today. The first track kicking off now is new revenue generating opportunities for optical networks. So looking at the opportunities for how to make money with optics. And for that, we're joined by Brad Booth with Microsoft, Stefan Rettenberger with ADVA, and Roderick Doughton with Orange Business Services. So that track will take us to about 11:30. There'll be a short break, about 15 minutes to refresh your coffees and come back, get settled, and then we move right into the next track, 11:45 kickoff, and that's going to focus on optics opportunities for the service provider edge. Again, I'll be moderator for that. We'll hear from Juan Pedro Fernandez from Telefonica. We have Javier Guerre from Telecom Argentina, Nirlay Kundo with Verizon, and Anuj Malik with Acacia on that one. For this track today, the flow of this will be a keynote, which we'll move into very shortly, from Brad Booth, principal engineer with Microsoft, give Microsoft's views and an angle on revenue opportunities in optics from their perspective. It's about a 15-minute presentation from Brad. We'll move to another 15-minute presentation from Stefan from ADVA. He's Senior Vice President, Marketing and Investor Relations. He'll give an ADVA view and some of the opportunities they see in optics. And then we'll move to, for about 45 minutes or so, a panel discussion format with Brad, Stefan, and Roderick we'll bring in for that. And we've got a number of questions prepared and topics that I think will be engaging. But also we do want to take your questions as you have them. Please do ask those electronically. We do want to hold about 10 to 15 minutes at the end of the panel discussion for your questions. So please ask those as they come to you. It is an important part of these events. We certainly like the audience to be engaged. Without further ado, let's move right to our first keynote. Brad Booth, Director, Next Gen Cloud System Architecture, Azure Hardware Systems and Infrastructure with Microsoft. Brad, I will hand things over to you to take the first keynote. Welcome, and thanks for joining us.
Thank you, Sterling, and good morning, and good afternoon to those in Europe. I'm not sure how many people are queued in from other places. I thought I would take a slightly different approach. I'm going to look at, as much as a lot of the focus that we've seen previously with NGON and a lot of these topics has focused on what's outside of the data center. I want to take a look at what's inside the data center a little bit more these days. There is a big transition, obviously, happening as data centers start to bring in, especially in the hyperscale area. A lot of people are hearing about AI, machine learning, and that's changing a lot of how these the use of optics inside a lot of our data centers, where traditionally, if you were to look inside a data center, you would find a lot of server connectivity is done with direct attached copper cables or DAC cables. And then, the rest of the row is connected with active optical cables. Still predominantly an electrical connection because the whole optics is contained within that AOC. What we're seeing, though, is as things start to change and as bandwidth starts to go up, especially in these really bandwidth-intensive applications, the need for optics and the ability for optics to allow us to change how we build some of these systems is becoming more important. So, in a machine learning environment, you have a fairly bandwidth intensive. You've got a lot of either GPUs or CPUs or even FPGAs for that matter that are talking to each other a lot of times in close proximity, but also, these can be scaled up to be cluster size, even considered to be, what's the potential to be able to take it to a data center size. And the reason why this is important is that if you look at the workloads that you want to run for machine learning, the larger connectivity that you have to connect all these GPUs and stuff, that gives you a much greater ability to run some of the larger machine learning jobs. So, today, most of this is run on a very small number of systems, maybe 16 or 64. The goal is to be able to get it to the point where you can run some of these really high-end machine learning AI jobs, things that allow you to do, medical research and other types of applications that today we're still somewhat constrained by the size of that environment. The other aspect that is occurring inside the data center is what's called disaggregation. And I know disaggregation is used in our industry throughout multiple meetings and multiple instances. This disaggregation is basically looking at how do I best use resources. So, for example, if I've got a server that is built with, hard drives and has memory associated with it, that's a very contained system. And memory is very expensive. So if you're buying DRAM, DRAM is a very expensive, portion of the building these servers. The ability to be able to separate that, to be able to resource pool memory or storage is actually helping us be able to control the cost and the power that's associated with building these data centers. So this is a little different than machine learning, where you have, the desire to have all these applications, all these GPUs or MPUs or ASICs talking to each other. This is a much more of an enclosed system. Now, the nice thing is that because it is an enclosed system, you don't have a massive scale. But what's happening is that you're starting to see this desire to be able to share the resource go beyond the rack. And as soon as you kind of go beyond either building a chassis or a rack-based system, that means you're going to have to look at using optics. So this is an area where, it's a very latency-sensitive environment. You've got, say, a CPU wanting to talk to memory. You can't have, microseconds or of latency. You've got to have something that can be in the nanoseconds, hundreds of nanoseconds of transition latency. So, this is definitely challenging how we build optics and how we move the data around, but it is something that is also fairly high in the amount of bandwidth. So one of the aspects of this, see if the slides change here, is all this is creating new topologies where we've typically built the networks designed where we use optics. We usually have a high level of redundancy. So in other words, if you're looking at a top of rack switch talking via an active optical cable to a middle of row switch, it has multiple uplinks off of that, 8, 16, however many you wish. Each of those links is done such in a manner that it's got a redundant path. That's not as easy to do when you're doing a machine learning or a disaggregation type scenario. And the reason for that is predominantly the cost. If you look at what it takes to build that, and if you said, okay, for all of these paths, I now have to create, 2 or 4 or 8 redundant paths, you start to realize the cost of building that system is just prohibitive. But you want to be able to build these large systems. So what you're looking at is, how do I change the development of my topologies to be able to do that? And it may be that you can't change the topology. The topology is what it's going to need to be able to support that workload. What you need to now do is look at the components that are being used to build these systems. And just to give it a sense of, the scale that we're dealing with here, if we start looking at cross-sectional bandwidth of these systems, what it takes, our typical infrastructure, that's what you would connect servers with today. If you look at Microsoft infrastructure, that's our connections from our servers to our storage and out to the outside world. The amount of bandwidth there, cross-sectional bandwidth, is pretty high. If you were to compare it in, hyperscale data center to, say, someone that has an enterprise data center or even an edge data center. But if you start looking at just the cross-sectional bandwidth in a disaggregation pool, for example, it's fairly high because the infrastructure isn't always pushing the maximum amount of its bandwidth. We'd say our infrastructure runs anywhere between 10 and 30% maximum utilization. That's a typical workload. If we look at the data center, our network bandwidth is not exploding. What we do is we have it running at a fairly low percentage so that if we have spikes or if we have failures, then we have sufficient capacity to handle that in the infrastructure. So our cross-sectional bandwidth is pretty low relative to the actual bandwidth capability of the data center. But in a disaggregation scenario, that's not true. You're actually maximally trying to use that bandwidth. And you've got a clustering of memory and resources that allow you to do that sharing, and you're constantly driving that and making use of that. So your cross-sectional bandwidth is actually pretty high. And if you look at machine learning, its cross-sectional bandwidth is in another step above that. So you're moving vast volumes of data. It performs a compute function or whatever machine learning function that it's doing, and then it shifts the data for the next node to be able to process that data again. So there's this movement of data constantly happening in a machine learning environment, and it's very, very high volume amount of data. So what this kind of drives us towards is the concept of fit versus function. And by fit, I don't mean, going out and exercising. I mean our failure rates. So when we have built things with servers connectivity with DAC cables, DACs are fairly reliable. I mean, we know that they're electrical connection. We can monitor that. Typically, we don't have too many active components associated with that connection. Therefore, their fit rates are extremely low. If you look at optics, optics have a fairly high fit rate, especially when the new optics are being introduced, because we're dealing with lasers and we're dealing with other components in these systems. Because these are active systems and we have lasers in them, if we have failures, that means we lose that link. Now, as I was explaining earlier, in these new topologies for machine learning and disaggregation, we don't have redundant links. So where we have used copper today for some of this, now that we're looking at using optics, suddenly this fit rate becomes a very critical element in designing and building these components. So that's an area that we're starting to look at a lot more when we talk to vendors about, hey, these are the optics that we need to use. What is your fit rate on these? What do we expect to see as a fit rate day one, and what do we expect to see as a fit rate, 5 years from now? And the reason why this is important, if you look at it, we do want that functionality in there, the ability to monitor and control that to be able to see everything that's going on. But that creates a tougher environment because, now we're asking for this low fit rate element with this high functionality, which is not what we'll find off the shelf today. If you go buy an optical module off the shelf today, it doesn't have everything that we need in it. It's not there with the fit rate, and it's not quite there with the functionality. So there's going to be a demand being placed on the module suppliers to be able to do some of this going forward. And the reason, that when we're doing all this, we start running into other things, what I like to call our nemesis in the environment, right? One of the biggest issues that we face today in data centers is power. That is our resource. It's how we use it and what we do with it. That's absolutely critical. So power that I'm using for doing transmission of information is important, but it's the power that I need to put towards those applications. So Microsoft operates a little bit differently than some of our other vendors. We don't sell networking, quote, as a service. We sell applications or infrastructure or storage or solutions or platforms as a service. And because of that, the network to us is a bit of a tax. So the more power I have to put towards my network, that takes away from the applications that I can run. Now, the other aspect of this that's really concerning for us, when we look at our 100 gig infrastructure and we look at transitioning from 100 gig to 400 gig in our infrastructure and even beyond 400 gig, one of the things that we're seeing is that power number is the proportion amount being assigned to the network is actually starting to grow. And that is a bit of a concern because if you look at 100 gig optics today, they're about, say 3 watts. If you look at the 400 gig optics today for the same reach and compatibility, they're 4 times the power. Yes, you get 4 times the bandwidth, but you've got 4 times the power, which is, what you have to deal with is how do I get rid of some of that in heat? So now I've got, something that's drawing more power, but it's also placing a greater thermal load on my systems. And so one of the things that starts getting investigated is how do we cool these systems? Traditionally, most people have probably heard, we use adiabatic cooling, which is more of an air-cooled system, bring fresh outside air in, run it through the data center. Air is a very low cost, in a sense, way to cool a data center, but it's not extremely efficient. The thermal transfer of heat with air is not nearly as good. You have to usually use massive, heat sinks on these. And in a lot of cases, depending upon the thermal load, as we're drawing more power in these systems, it's placing a greater thermal load. And to be able to cool those systems, usually, a lot of these guys, a lot of the switches and servers have fans in them. And if you look at a typical 1RU top of rack switch, it's got a bunch of little 1RU fans in the back that are just running as fast as they can go to cool those systems, especially if we look at the 400 gig systems. And that fan is actually drawing a very significant amount of power. So I'm having to pay power to cool and then pay power again on top to have that infrastructure. So one of the ways that we're looking at changing here is how do we treat the thermal? Things like cold plates are being investigated, water-cooled systems, liquid immersion systems. So that's all being done to consider. And how do I play with optics in that? So I think one of the critical aspects of all of this is understanding the topology differences that we're seeing in our data centers. Don't assume that what I did 5 years ago is what I'm going to be doing 5 years from now. Things are changing. We're bringing in things like machine learning. We're bringing in things like disaggregation, which are changing the topologies. Low fit rates are going to be absolutely critical for these non-redundant links. And that's why I was saying understand the topology, because if I do have non-redundant links, I am going to need to have low fit rate components for those links. The other, okay, that didn't build out correctly. Well, I guess I lost a few of the points there. Let's see if this will work. There we go. Power is a limited resource, and that is absolutely critical. When we build data centers, we are built with a very specific amount of power assigned to us, and it's not like we can walk down to the grocery store and say, "Hey, I need more power." That doesn't work for us. A lot of public utilities and various other cities and stuff are very focused on how much power are we using. Usually once we're assigned that power, that's what we get, unless we build our own power resource. And that's why you've seen, ourselves and others look at, how do we drive, how do we create new power resources? Do we create wind turbines? Do we use biofuels, stuff like that? So, power is very limited for us, and we have to treat it very carefully. And then finally, as I said, heat extraction, what we're finding is that the ability to deal with the thermal loads, the ability to pull the heat away from these systems is actually becoming extremely important. It improves the performance. Lasers don't like being hot. And so we're looking at ways of cooling them. But if that cooling method is different or more difficult, for example, a liquid immersion system is a very different operating environment than an air-cooled system. How do we operate with optics in a liquid immersion system? I can't simply, go and say, okay, I'm going to pull this out of the tank and change out the optics. So again, this is where the fit rate becomes very important, because once it's there, we want to operate in what is known as a fail-in-place type of mode. So understanding how we're building the next generation data centers and how we're cooling them and the implications of that directly impacts how we look at the optical modules and the optical connectivity that's necessary. And that's all I had to share. Thank you, Sterling.
All right. Yeah. Thank you, Brad. I got to say, looking at your slides in advance, the one with the guy doing the plank, I was wondering what the optics angle there. I didn't know if you're going to do some exercises for us or what, but interesting presentation. Yeah. Good stuff. We'll continue the discussion when we get to the panel, but definitely got some interesting thoughts for me to follow up with you on. Let's continue on. We'll bring in ADVA, Stefan Rettenberger. I've known for many, many years. Probably familiar to many of you, but he's with ADVA, and he's going to give the supplier side view of this topic. Stefan, I'll bring you in now to take the next keynote.
Yes, thank you, Sterling, and also welcome from my side. I'm actually based in Europe, and like maybe some of you attending the session today, you would have loved to be somewhere down in France or maybe in Barcelona this year. Who knows? We might still get together in December in Barcelona, but for the time being, I think this virtual setup will work just fine. In ADVA, we're in the business of developing, manufacturing, and selling networking equipment. A lot of it is around fiber optics, WDM technology. We also do packet edge technology and network synchronization. Today's keynote certainly goes back to the roots of the optical layer, WDM technology, and some interesting new angles and opportunities to get more from this technology than just being the cost per bit improvement technology. And with that, I guess I'm going to try to jump right into the slide deck. here. Let me see if I can forward this. Yeah. So disaggregation in the optical layer is not a radically new concept. And we're talking here what I would call the horizontal disaggregation. So separating a terminal from a line system is something that has been discussed for quite some time. The main reason is that when you look at the different assets that you have come together here in an optical network, clearly there is the physical fiber, the glass and the ground. And yes, there has been innovation in fiber technology, and there's companies doing a great job further improving things like loss and other characteristics. But ultimately, once fiber's in the ground, you're trying to use that asset for decades. And Sterling, when you said you've been in this industry for decades, I remember that I'm also here for several decades, and fiber certainly is also something that normally is utilized over more than just a few years, again, several decades. The optical networking system that is trying to utilize that fiber efficiently typically has two main components. One is the front end, the terminal that is generating these high bitrate light pulses. And the line system is doing the job of grouping those light pulses, making sure the wavelength is going through the network, ending up in the right place, the signal-to-noise ratio is not degrading too rapidly, etc. And while both areas have their own merit of innovation, it's typically with the line system, there's not that much happening. So the life cycle is significantly longer. We have customers that are utilizing the line systems for 10 years or even longer. However, the terminals, this is where the high-speed optics come to play. That's a little bit like the compute industry. So every 18 to 36 months, you see a higher processor speed in the compute industry, and you see higher bit rates and baud rates in the optoelectronics that allow you to further improve the performance of the terminal and ultimately driving down the cost per bit. So long story short, there is some merit in recognizing these different speeds of innovation and life cycles, and see if you can treat the terminal and the line system under slightly different angles and separating the two. In the old world, clearly, vendors were trying to just have new generation plug-in modules on the terminal side, but still treat the system as a single entity. But more recently, there's additional market dynamics happening around optical networking that further show the merits why separating terminals from line system is actually a good and intelligent thing to do. This is a bit of a word-heavy slide, but let's just start in the upper left-hand corner. And that's an architecture where Brad and Microsoft actually have done, even before 400ZR showed up on the radar screen, did some interesting stuff and saying, why can we not take intra-data center technology that is very cost, space, and power efficient and utilize it for metro distances? So they used some direct detector plugs for 100 gig. And with the help of a good line system, we're actually able to extend that reach all the way up to 80 kilometers. And again, it has a lot of benefit in terms of space and power consumption of that optical system, that transceiver that sits directly in the data center switch. And secondly, you're trying to leverage the cost points of datacom in a telecom environment. So very smart thing to do. Microsoft's been leading here in the metro environment, and 400ZR is probably the next generation where plugs in data center switches may be an interesting network architecture that pretty much eliminates the need of a bespoke terminal, but may impose additional requirements in the line system that is then supposed to carry that light pulse. There's been always different waves of long-reach optics, WDM optics sitting directly in switching and routing gear. So that's another use case where you would say a traditional terminal is not the right approach, but the line system needs to be able to talk to that optical interface, possibly control it. We've done some interesting work with one of the major switch and router vendors here for many years. And then, of course, there's the whole speed of innovation on the transponders themselves, where we're approaching the Shannon limit. There's now new modulation schemes, higher baud rates, all of these requiring different spectral bandwidth, and having different reach capabilities in the line system needs to be mindful of what is being fed into the line system and whether or not the performance is then sufficient to get the light pulse where it needs to go. On the client side, clearly 100 gig is a lot of a very popular interface in the hyperscale environment. But outside, you still also have lower speed interfaces. So we need to be mindful that a terminal typically needs not to only support the highest client bitrate interface out there, but typically also a mix of legacy interfaces with lower speeds. And it's a design consideration to see how you best feed those into the system. The requirements in the line system are also changing. The older systems were using fixed grid, ITU type of environments, making sure the componentry, the channel plan, everything is well defined and standardized. Again, with newer generation front ends, we're losing some of that grid and we're going gridless or flex grid. That means we can route different amounts of spectrum through the line system. That's creating new opportunities also for services. And last but not least, however, we also, as I mentioned earlier, a lot of the line systems out there have not reached end of life. And it's definitely something where, as an innovator, we need to be mindful that there is merit in sweating the assets and utilizing those systems even longer. Now, so we definitely then, with all that, have a paradigm shift. In the old world, I guess, an optical networking solution, a lot of talk was about the terminal, the higher speeds, and this is where the industry conversation was happening. The line system was also often very, I guess, I don't want to say disrespectfully, but treated as common equipment, something that you must have, but there's not a lot of differentiation in there. And of course, there's a management layer on top that was needed, I would say almost seen as a necessary evil in the old days. In the new world, that is different. The terminals still matter because the terminals definitely define how you utilize the spectrum, but the line system really is the element that unlocks the spectrum. So, and I'm not just talking C-band or L-band or extended C-band, it is all about removing guard bands, removing any of this fixed grid technology so that the spectrum is a ubiquitous thing that you can utilize as your application requires it. And the network management that used to be a necessary evil to command and control the network is now seen as a tool for automation and possibly letting even applications decide directly how they want to utilize that resource pool, which is given pretty much bandwidth for whatever type of data transmission is required. So we're moving from a lowest cost per gigabit mile to something that is a interesting resource pool that can be generated, that can be generating new revenues. One of those opportunities that we have discussed with one of our customers is, why can we not sell spectrum as a service? And the question is, why can't you? Yes, you can. So again, in the old days, you would sell either the glass, so pretty much a dark fiber, or you would sell a bit pipe, in the old 10 gigabit Ethernet, 100 gigabit Ethernet, 400 gigabit Ethernet pipes, etc., that are bookended and controlled by OE equipment. In the new world, the line system is actually something that can also just make spectrum available. And as a wholesale operator, you can say, I operate the line system, I own the fiber and what used to be the commons, and I assign a certain amount of spectrum to my power user. Interesting use case, especially for those that have those power users, like internet content providers who may need transcontinental or some type of long reach capacity and would like to maybe decide themselves how they utilize that spectrum. So it's definitely an interesting new angle that technologically was not possible and available before. And it's something that, depending on the operator skills and the customer base that they're serving, could be a very interesting value proposition with merits on both sides. We've done some of that work actually with one of our wholesale customers. So the network that I'm showing here is sometimes referred to as the Baltic Highway. It starts in the Baltics, goes all the way down to Frankfurt, was built and designed specifically for express capacity from the world's largest internet exchange in the Frankfurt area all the way up into the Nordics, where it's an interesting place in terms of cooling and the cost of real estate to have large-scale data centers. And so the express bandwidth is being sent over a flex grid network. So we no longer have the fixed grid filters in there. And the network was actually not defined in terms of, do you want 100 gig E-pipe or 400 gig E-pipe, but it was defined by what you see in the top middle corner here. How much spectral bandwidth do you need? What's the power that you're planning to launch? This is what the receive power that you would need. And this is the OSNR, so the GSNR, the general signal-to-noise ratio degradation that you can expect. And we were showcasing that, what you see on the lower end, using that spectrum over different distances with a terminal that can adjust to always exactly the maximum data throughput for any given GNSR degradation, which translates into a reach that is possible. So we've done short to reach, and I guess short to reach in such a long distance network, something like 1,000 kilometers, being able to push 500 gig through the assigned spectrum. And you see, as you go further down the table, once you go close to 6,000 kilometers, we were still able to push 200 gig through that spectrum. And I think that creates an interesting opportunity for the wholesale provider, saying, I do no longer need to worry about the terminal. I can actually just provide the spectrum, focus on owning the fiber and building the flex grid network, and let my power users then decide and define how they want to utilize that spectrum. And that, of course, means the control of how you feed into that spectrum, which is a function of the terminal. So I said it at the beginning, the terminal decides how much bandwidth you can get through that spectrum. That's terminal technology. And clearly, terminals are typically designed for different use cases. Greenfield is always easiest because you can pretty much start with whatever spectral definition you want to have. You go for the highest baud rate, complex modulation schemes. I think the product generation that is currently shipping is something like 600 gig per lambda, often used in a 75 gigahertz grid. For point-to-point, the DCI links, giving you something like 40 terabits per second on that link. The same technology can be used for flex grid, like I showed on the previous slide. In that case, you may try to throttle either the baud rate or use slightly less complex modulation schemes. Use a channel spacing, although it's flex grid, that might allow you to slice the spectrum into somewhat predefined portions, and then say, maybe go to 100 gigahertz channel spacing as the entity that you want to sell, and something like 400 gig over a long reach distance is easily possible. And last but not least, of course, these terminals also should serve things like open cable submarine, but also terrestrial networks where older generation fixed filter ITU 50 gigahertz or 100 gigahertz grids are available. And again, new generation terminal technology can push something like 200 or 300 gig through a spectral window that was originally designed to carry only 10 gig in the old NRZ world. So interesting innovation on the terminal side, but the revenue opportunity really is in making that spectrum available to those power users. This is just a quick text summary in terms of what you should watch out for when you look for terminal technology. So a lot of the differentiation is in the core processor, the DSP, the digital signal processor. Dual core technologies are interesting, supporting multi-services, supporting fractional QAM, so different modulation schemes to allow maximum use of spectrum, some shaping. So these are typically features that you can get in a good terminal today. That means also that you can then use single optical carrier or dual carrier. You can create 1200 gig dual optical carrier channels. You can get really long reach because you don't need to go to complex modulation schemes, etc. And the density is phenomenal. I mean, Brad mentioned that space and power consumption is relevant. So these new terminals give you something like 3.6 terabit from a rack unit. Different type of client interface support, 100 gig, but also breakout to lower speeds. The thing is, no matter what parameter you change going forward, you increase the baud rate further. That means you also increase the spectral width. You go to more complex modulation schemes. That means your reach is going down, etc. So we are starting to operate around the Shannon limit. And so while different constellations and parameters may have better benefits in one application or the other, it's not as simple as it used to be for the last 2 decades, where we just say, let's increase the speed and the TCO will go down. It's all about how do you utilize the available spectrum and what's the cost per bit in that application. So again, while terminal innovation is exciting, it's becoming less relevant as we're dancing around the Shannon limit going forward. Good. Third element, command and control, fairly straightforward. If everything comes from a single vendor, then typically you have something like a domain controller, and the optical network is treated as a domain that you see on the left-hand side of the slide, the scenario 1. You can, of course, mix and match, so the terminals can come from one vendor, the line system is already there, or is something that you just newly put out there without the terminals. In that case, you probably still want to have a domain controller for the line system. Terminals could potentially be controlled directly out of your overlaying OSS, or vice versa. Of course, you could then say you put the terminals in the domain controller and the OLS runs under somebody else. SDN has really made some great progress bringing the industry together in terms of well-defined interfaces and ways to talk to network elements directly. Breaking out a line system into individual components has still proven to be relatively difficult and complex because of the analog nature of that middle bulk here. And I think in terms of commercial deployments, a further breakout of that middle block has not been very popular so far. Good. Final topic for this presentation is artificial intelligence, machine learning, etc. Does that play a role in the optical networking space? So there's one use case that we have actually out there in the field, and that has to do with preemptive maintenance. So we're collecting lots of data from our most popular transceivers. So we have tons of equipment out there using 100 gig CFP pluggable interfaces. These things are easy to use. We ship great volumes, and but of course, with big volumes come also a certain failure probability. And we said, rather than letting the customer tell us when the thing has failed, why don't we monitor certain behaviors of these interfaces, try to correlate certain parameters and see if that allows us to predict that this unit is actually starting to run into trouble and might fail. And this is something we've done in the artificial intelligence context. So we're monitoring the plug, as you see here on the left call out. If bit errors are on the rise and the curve is having a shape like here, then we recommend a exchange of that module. So the exchange can be scheduled while the network is still up and running. You then just simply exchange the plug, the transponder continues to function, and you continue to be in business without having any network downtime. Again, large quantities of these pluggable interfaces allowed us to further increase network availability and definitely have a better customer relationships with those guys that use large quantities, where one or the other would just fail. That's normal statistics. Good. To sum it up, so the innovation in the optical networking space has moved from terminal only. Terminals are still relevant, utilizing the spectrum that's being made available. But what's making the spectrum available, unlocking the spectrum, is the line system. And there's more and more interesting scenarios where line systems have to do different things to be a good fit for a particular network application. So pay attention to how open, how versatile, how capable that line system is as you make your selection here. The interworking at the physical layer, again, is becoming more difficult because you now have a vendor mix between the terminal and the line system. You may have just plugs, direct detect, 400ZR, high-end optics, complex modulation schemes, different baud rates, etc. So not as easy as it used to be, something that the line system needs to handle. Command and control, SDN and the well-defined APIs help to still manage the whole thing. And clearly there is no one-size-fits-all. So I guess in the old days you had a long-haul system and you had a metro system. Today the range is much more diversified, and there's more buyers for optical networking technologies out there than in the old telco-only days. So with that, it also means that depending on the skills that you have as an operator, you may be able to sell dark fiber only, or monitor dark fiber, or align system and bring spectrum as a service out, or you may want to sell it bookended. Again, the skills that you need and the technology that needs to go with it depends also a little bit on the organizational setup. This is why the customer focus also, from our perspective as a vendor, is an important one. And of course, everything is in the context of low touch, less human interaction, make it as plug and play, as easy to use as possible, where machine learning, AI are starting to help with the automation, but also helping to improve network availability. Good. And with that, I guess I hope I was able to build a case that optical networking is much more than plumbing and driving the cost per gigabit mile down. There's also some interesting capabilities that also are a good basis for new revenue opportunities. And with that, Sterling, I think it's back to you.
All right. Yeah. Thank you, Stefan. Definitely interesting. I like this concept of the spectrum as a service. As we get into the panel discussion, I'll definitely revisit that with you and see if I can just pull some more details on how that may work. But that's definitely in the spirit of what we're trying to do with this topic, which is a difficult one for sure, and uncomfortable to a degree, which I'll show in a moment in my own intro. But let me introduce our panelists here. So for the remainder of the 45 minutes we have, we'll do discussion and Q&A. As I said, I've teed up some topics to go through, and then we'll take your questions. There's already quite a few good questions have come in, so that's great. Our panelists are bringing back Brad Booth from Microsoft, Stefan, of course, from ADVA, who just presented, and our third panelist is Roderick from Orange Business Services. So let me bring in Roderick now. The other two have essentially made introductions, but since you are the new person coming on the panel, I'll give you a moment just to introduce yourself and how you fit into the topic. Roderick, okay. Are you there? Yes.
Yes, I'm here. Okay. Thank you very much, Sterling, for having me be part of this digital symposium today. Hello, my name is Roderick Dutton. I'm with Orange, based in the US. So we are part of the project management team with the build network for the in the US domain for our wholesale infrastructure network, but we're also being merged with the global enterprise group for OBS, Orange Business Services. So it's basically one common team, one common network from the cable landings to the US backhaul. So that's basically the scope.
Okay, excellent. And we will also bring you in a moment. Let me give a few intro comments, but I won't spend a lot of time. I'll kind of just quickly go through this one. So there's certainly mega trends driving service providers globally, really just all of society and business globally. The World Economic Forum, as I think most of you know, is really seized on this idea of the fourth industrial revolution. The point here is that the technologies that this industry builds around 5G and wireline and cloud and edge all are enablers to this fourth industrial revolution, which is going to have a tremendous impact on not just our industry, but really all industries globally and all of society as a whole. That's the mostly good news. The tough situation, though, is that operators face a revenue challenge globally. This is data from Omdia, and it's their forecast out through 2024. What we've seen is, when we went through 4G, there was benefits to a degree to operators. I think there's a lot of agreement that the OTT providers were really the big winners in the 4G revolution. So, if we look at just global revenue, it's relatively flat, and yet the capital spend to maintain and upgrade networks for network operators, and these data points would exclude the Microsofts of the world. They're a bit of a different animal, but for traditional telecom providers, this is the situation. Capital intensity is increasing as we go forward. So revenue as a whole, relatively flat. Capital intensity increasing from Omdia forecast for about 16.9% 2019 to 17.8 2024. That's the red line you see on the chart. So mobility is in there. This is all wireline, wireless combined together. A lot of the opportunity, as we know, comes from mobile, but mobile has a lot of challenges as well, as I show here on this slide. The data on the left is Cisco's VNI traffic model. If we look back, even not on this chart, but back to 2010, mobility as a share of IP traffic was just about 12%. As you look out through 2022 and really just the early years of 5G, mobility is going to rise to about 22% of total internet traffic, according to the Cisco studies. So it's becoming a meaningful piece of traffic, not just an afterthought, but really a good chunk. And then, of course, going forward, the share will continue to rise. But if we look at the mobility situation on the right, which comes from Omdia, and this is all mobile. So it's mobile revenue, ARPU, and CapEx, but just mobile, but all generations of mobile. You can see the CapEx to support those mobile services is rising faster than the revenue from them, and the average revenue per user is on a downward decline there. The orange line is the ARPU. So, you know, there's opportunities, but they're always up against this revenue situation. Where does optics fit in? It's not just about optics, of course, but optics is a big chunk of that CapEx spend, number one. And number two, optics really is the underpinning for many services. It's basically a foundational technology. So it's in the mix at any level. And it's a piece where operators can generate revenue. So they're certainly looking at optics more and more going forward as ways to boost that. So this is a forecast of what can be, but service providers like Orange and their counterparts globally are working very hard to change those curves, which is really where we see a lot of the focus right now on the new use cases around 5G. With that, let me just jump right into it. So the heart of the matter is opportunities for new revenue. So I'll dig into this with each of our panelists. Let me start with Stefan. You gave a little bit of a overview of the spectrum as a service. I'll bring you in first. If you can just kind of add to that. The buyers of this, I don't know that there are any, but how worked out is this as a concept in your discussions with service providers? Anything you can give around uptake and where this is, or where you likely see it take off first?
Yeah, I think the example that I showed in my slide deck is probably the most advanced one, because that is a longer distance backbone express network that was built for power users. So I think when the network was built out in a flex grid environment, that Baltic Highway, the idea was that big internet content providers would need express capacity. Research and education networks might use express capacity, etc. And in that context, the customers always demanded, give us more than just a 100 gig pipe or multiple of those, give us access to that spectrum. And the question was, is that possible, and what would need to happen? And can we define actually in a non-OEO book-ended scenario, what performance people can expect there? And so we worked with them and said, yes, you can. I guess you've got to have a certain level of, again, launch power to get, your receiver needs to have the falling window for the receive power. You can expect this OSNR degradation, and you can slice it in particular ways. So you need some sort of a gateway, a spectrum gateway to commercialize it. But I see that's the most interesting use case, where you say you have a high amount of bulk, high power, bulk capacity, high power users that are also quite knowledgeable and have, I would say, a lot of confidence and a strong do-it-yourself mentality. And that you do find, of course, with the internet content providers that say, give me some raw piece of equipment or give me some raw bandwidth. I have the expertise, the confidence that I can make this work. And in that case, the wholesaler doesn't need to go through procuring OEO terminals and those things, because that's now part of the client that would just simply lease the spectrum and not demand an OEO handover like they would normally do.
Okay. Brad, over to you. A couple of concepts that you had brought up when we had our discussions. Onboard optics and co-packaged optics are something near and dear to you. If you want to give a little bit of a view of your thoughts on why that's relevant for this discussion.
Well, I think the relevance to this discussion is that this starts changing how the operating model works. When we've traditionally built these, as separate components, and Stefan, kind of mentioned that, right? Here we had a system that we wanted to be able to build with kind of an off-the-shelf. We could buy an off-the-shelf switch. We could buy an optical module that fit into that socket, and that's what we called, that was the Infi Colors program to enable us to set up our regional networks. And if we look at that, traditionally our faceplate pluggable optics have offered us a certain operating model, which is fine if you look at the way optics are used today. The amount of optics that are deployed in data centers today, and optical connections, and that doesn't include the active optical cables or the DAC cables, but the amount of optics we use inside data centers and inside networks in general are, easy enough for us to handle. When we start looking at transitioning, if we said, okay, we're going to go optics everywhere, and then I go and tell my operator, or you tell any system operator, it's like, oh, guess what? Everything's going to be all optics all the time, and we're going to be building, hundreds of thousands of optical links inside a single facility. And then you tell them, guess what? You have to plug these optical modules in. You just get this glazed look in their eyes of, there's no way we can do this. And so I think one of the aspects of this is we're trying to figure out how do we change the form and function of this. And onboard optics, which has been around for years. I mean, onboard optics is actually one of the original way optics actually started. A lot of those systems, the reason we went to these faceplate pluggable is it allowed us the chance to replace them. And touching back on the whole fit rate thing, when we start integrating these and making it easier for us to build these systems, the fit rate becomes pretty important. And when you have high volume connectivity with optics, you realize, hey, I really would like to have that optical module installed by a system integrator or a manufacturer rather than having my person in a data center do it. And then you get into something like the co-package optics, where that's actually integrated with the ASIC. And now it's like, how does that work for failure rates? How does that work for reliability? What am I going to, how am I going to operate if an optical engine that's integrated with this part fails? And so, this is changing some of how we look at it, but some of this is necessary because what we're seeing, back to that power and thermal thing, the amount of power we're burning to go from an ASIC to an optical module is significant. I mean, that curve is not a trend line that's going down over time. It's actually flattening out, and what we're seeing is that signaling is actually starting to draw more power than it did in the previous generation. So, like, even if you were to go back a single generation and you say, okay, I'm going to go forward and I'm going to still have that same length of trace on that PCB, and I'm going to be using really high signaling rates, suddenly you realize that you're paying for that. You're not actually getting a reduction in power per bit. Your power per bit number is actually starting to trend upwards. And that is not a trend that we want to see. So the only way you can do that is shorten that reach from that optical module to that ASIC. Onboard optics is one step, but the real one that people are looking at, and that's why there's a big push in the industry right now, is around co-packaging.
Okay, great. And in the interest of time, we're going to move on to the next topic in a second. Roderick, I'll give you the last word, though, on this. We've heard from a supplier. We've heard from a hyperscaler. As a more traditional network operator, converged operator, anything to add in terms of promising optical revenue opportunities that you are seeing? Anything new that comes to mind, or is it more business as usual for optical business services?
Well, if you take the OTN part of this generic discussion as well, because what is happening is OTN has more or less evolved as the default bearer service, if you wish, coming from the carrier perspective, the bearer service for international or multi-services transport across the optical network. And that is no longer just dumb pipes. You're actually delivering a protocol mapping mechanism across the multiple optical operator, because national are going to have operated in different domains. So where does this OTN the mechanism fit within the packet-centric world? It has adapted very well, in that you find that the flows can be encapsulated into that OTN, the ODU container, the ODU flex function. So we have the case where we handle the legacy services as well as the new packet flows on an international basis. So optics from a perspective is alive and well. The only thing I will say is TDM services are being lost with this new packet grooming engine. That's one of the major concerns.
Right. Okay. Good. Let's, as I said, in the interest of time, we do need to move to the next topic. Roderick, I'll keep you on for this one and let you kick off this topic as well, and then I think I'll bring in Stefan. If you gave a little bit of presentation on this, but Stefan, you may want to augment your comments. Open and disaggregated networks. We do always talk about them in terms of saving money. From Orange's perspective, Roderick, do you see a revenue play, and do you look at things differently, this partial disaggregation concept versus disaggregation? But really the biggest question is disaggregation a moneymaker opportunity, or is it just a cost reducer?
Both cases. In the immediate respect, it is a revenue reducer in the sense that the cost of deployment. The fact that you can have now with partial disaggregation, as Stefan alluded to, whereby a subsea open line system can terminate directly into the terminal elements, the SLT of a third-party vendor in the terrestrial backhaul. That is happening today, right now. Now, that gives the carrier best-of-breed choice to avoid a multi-vendor or a vendor lock-in scenario. Where we and from a full disaggregation is more happening on the terminal elements, like the Blacklink transponder client handoffs. So, no, that's alive and well again. Again, you get multi choices for deployment. From a revenue standpoint, there's a convergence taking place, and it's sort of you have now the embedded programmable optics in the network elements from the core to the edge, along with your control plane, SDN enabled control plane, and that cloudification taking place in the edge network. You're almost setting up the blocks for infrastructure as a service, as a revenue play. Future. That seems to be so the network itself is more or less the revenue item.
Right. Great. Stefan, I know, the spectrum as a service concept fits into this open and disaggregated. It essentially is an enabler. Is that primarily how you see the revenue opportunity with it open and disaggregated, or is it broader for you, or, is it still primarily really a money saver for your customers?
Well, I think clearly, if you save money, you can do and try new things. And Roderick said subsea installations were outrageously expensive, and I guess you would only do them so often. If you now can say you have an open cable there, and you can simply upgrade with terrestrial technology at the terminal side, it frees up opportunities elsewhere. If you're saying infrastructure as a service is the future, then infrastructure can be the physical glass, it can be the spectrum, or it can be a fully book-ended OEO bit pipe. So also here, you have choice, and choice creates opportunities and new creative ideas. But that all evolves around separating a terminal from a line system, also supporting the colors architecture that Microsoft built. You can only do that if you have a line system that is actually allowing you to transport that interface over the required distance. So again, I think that openness, that disaggregation creates opportunity for new network architectures, for new scenarios, and those ultimately will have business cases where people make money with that. Separating the hardware from the software, which is the other dimension of this aggregation, has not really been a success story in the optical domain. Reason being that if you just buy white box type of hardware with optical plugs, you add an operating system, you need the end-to-end engineering, etc. The cost savings there are not phenomenal, and you still have choice out there. So when people said we want WDM compact, custom-built terminals that give us big fat pipe type of capability with a small footprint, low power consumption, at least 5 vendors responded to that. That's different from a data center switch that needs maybe just lots of merchant silicon and some self-programmed software that the likes of Microsoft can program much better than we ever could. So I think in the optical domain, it is still the complexity and analog nature of the hardware and the cost model in that context that makes a vertical disaggregation, separating software from hardware, more difficult from a business perspective and less attractive in terms of a commercial mainstream.
All right. Brad, if you want, I'll give you the last word, particularly on the vertical disaggregation. I'm wondering if you have any thoughts on whether that is beneficial, or is it primarily the horizontal, the line system type of disaggregation that Microsoft pursues?
Yeah, predominantly it's the horizontal. We, as you know, Stefan knows, we do a lot of our own operating systems for our networks, both internally and externally. That's why we're a big proponent of the open line system. It gives us an ability to mix and match best in class, and actually, it also helps us a lot in when we build a lot of these regional designs. Supply issues actually is, we're seeing that today. We even saw it, prior to COVID-19. But when you start having to deal with operating in certain countries or building new data centers in places throughout the world, you want to be able to have the ability to mix and match components and be able to build these systems quickly and efficiently. And that's pretty difficult if you don't have the ability to have some level of disaggregation there.
Okay, excellent. Let's move on to our next topic. Brad, I guess I'll keep you on to start this, and then maybe ask Stefan as well if he wants to comment. But a lot of the opportunity we hear about is around machine learning, AI. Can you speak to any examples, of course, to show would be useful, but it really just speak to the importance of that trend from Microsoft's point of view in driving innovation?
Yeah, we've been using or offering AI as a service to multiple people and customers throughout the world. I mean, people have been using it, from everything from developing better beers to, figuring out how to do better farming and stuff like that. So as an application, it's very useful. What's interesting is how we're starting to turn that inward. Using AI, machine learning type algorithms to analyze our networks and traffic flows and how we can potentially improve those systems, improve the manageability of those systems, I think is critical. In an environment where you've got vast volumes of people relying on us to maintain their data and provide them access to that data, that becomes pretty critical that you have tools, because humans can't do it enough on their own. So you need a set of tools that can actually go out and analyze these things and say, hey, look, we've been looking at the traffic flow patterns here. We're running it through an AI algorithm. We realize if we, reroute the traffic this way, or if we take that node out of service and replace it with this new one, that we can get better performance or offer our customers better performance than what we've seen before. I think that's where we're going to start seeing some of this kick in, and I think it's important for people to understand: are we using these tools to help provide a better service? And I think that's going to be one of the critical elements moving forward for AI and machine learning.
Would you say, from Microsoft's point, is it entirely homegrown, all of your AI and machine learning, or do you go to outside sources for some of that expertise?
No, actually, some of it is homegrown. Stuff that we use for our internal stuff typically is homegrown, but we provide that as a service, provide the infrastructure as a service for people to build their own AI algorithms on. So I think that's where we're going to see growing trends. It's, yes, we're a big software company, but we do rely on the larger community, even in our Sonic operating system that we use for running our data centers. We don't do all the operating system ourselves. We work with our partners in the industry and others in the industry on an open standard. That's where software being open is actually being very helpful. It allows other people to come in with innovative ideas and creations, and allow us to look at that and say, hey, I know I can use it in this form, or I can make it available to customers in this way.
All right, excellent. Stefan, anything from, do you have examples to point to specific to optics for, AI and machine learning being effective today?
So in the optical space, as I had shown on that one slide, we're already using machine learning and AI type of intelligence to help improve the network availability, again, in the context of preemptive maintenance, trying to identify patterns of individual modules or network links where we say, well, this link seems to be degrading, this particular module seems to be degrading, etc., and therefore have a very relaxed and simple replacement procedure rather than a response to a catastrophic failure. So the customers of our customers have a better experience because there's pretty much no network downtime, and our customers are happier because they don't need to respond in an emergency situation. They can just simply schedule such a replacement and are not being surprised by something degrading and ultimately failing. And then there's another business unit in ADVA, which is probably taking a little bit too far, but we do network synchronization technology, and there we're using artificial intelligence to see any changes in the accessibility and availability of satellite-based timing. So we look at different sites, and especially in the context of 5G, network synchronization and timing is extremely important. So if all of a sudden a particular site that had view of 3-4 satellites is losing one satellite, is there a tree growing over? Is there some construction, something changing in the way that antenna is being surrounded? So we're able to also improve here the GNSS availability and preemptively avoid any vulnerability in this very mission critical function, which is timing. But these are the two use cases that we have commercialized, and a couple of ideas floating around, but that's too early to say now.
All right, let us move to it'll be our last topic, and then I want to allow some time for Q&A. We do have some good questions that have come in, but Roderick, it's a big topic. We're going to have to give basically a 5-minute view on it, but wholesale wholesale revenue opportunities for 5G from an optics perspective. Do you see, from Orange's perspective, do you see anything around 5G really providing new wholesale opportunities for Orange and for other telecom network operators?
If I would say in general, it will be the 5G, the transport, the network access. So where you can have the mid-haul aggregation and the backhaul to the core provided as a service. I mean, one thing that came to mind recently with the I guess the cloud-centric open architecture, where you have VMware as a cloud provider partnering with Dish Networks in providing their 5G solution. Perhaps there's room for 5G as a service from a provider perspective.
So one of the points I put here is managed front haul services. At least in the U.S. so far, go ahead.
Well, okay. Continue. Sorry.
Oh, I was just going to say, in the U.S., we've seen most of the interest in from wholesale. They're just buying dark fibers. As a wholesale provider, preferably they would want to not just sell or lease fibers, but be able to monetize a bunch of wavelengths out. I don't know where that's gone lately, but I don't know if Orange is seeing interest in this managed front haul type of service or CRAN as a service, or is that just a kind of a false hope for wholesalers?
Not notably CRAN, but more like the Open RAN, whereby you have now that the front haul could be more, let's say XR optics. That's a banded solution whereby, yes, you could now have front haul as a service whereby you have programmable bandwidth between the RRUs and the distributed unit. So that type of thing, but that's a future versus just pure fiber, because yes, with the high densification for 5G, it's not really so much of a play there.
Right. Stefan, anything to add in terms of, ADVA's historically been pretty involved in, at least as a company, in backhaul. Looking across backhaul, mid-haul, front haul from an optics perspective, any opportunities that ADVA is pursuing that are new that you'd like to share publicly? Maybe some of the stuff you don't want to go out and tell all your competitors about, but to the degree that you want to talk about it.
Yes, I mean, I think, first of all, there's no question in my mind that 5G will definitely need a wholesale type of environment. I mean, we're talking a densification of radio heads in the factor of 5 to 10 in certain areas. And you've shown the CapEx requirements versus the revenue opportunities for the mobile network operators. Is no possibility to economically build out those 5G infrastructures individually, every MNO by himself. So huge opportunity for wholesale in my mind. The lowest level of wholesale is glass, so the dark fiber model that you had mentioned. We have seen more and more requirements where there should be monitoring in that glass, so that either the fiber provider can see if something is going wrong with that cable, some bend, some higher attenuation, etc. So I would call it out-of-band OTDR type of monitoring, in-service monitoring. So you have a service-level agreement on glass, which is different from what you normally have in dark fiber arrangements. There's definitely the need to deliver network-based timing. So in the 5G environment, many of those endpoints won't have visibility of satellites, and it's important to bring that through the network. That's a great wholesale opportunity. And then, of course, interesting topologies like in a G.Metro point-to-multipoint fiber plant, we're using the dimension of wavelengths to separate the different traffic streams and even introduce things like slicing in there. So I think it is definitely a playing ground for wholesale with different levels of value-added services. I strongly recommend do not just sell the glass, but add some value-added features to it. So you can charge a premium and help the mobile network operator to actually solve a couple of things that he would otherwise have to solve in a much more expensive and, again, individual way rather than sharing that service then.
All right. With that, I know we're running short on time. Let's jump into, let's see, questions come in, quite a few of them. I'm just going to pull up the window. Let's start with, some of them have called out people in particular, so I'll kind of start with those because they're easier. I think this is more particular for Brad here, so I'll call you out. Some processes in optical networks are still manual, in particular switching and management of the physical layer. What can be expected as optical integrated components evolve?
Yeah, and that's an excellent question. As we look to integrate these things, this is where it changes the operating model. Where we have traditionally had, it's funny how we talk about disaggregation of hardware, and here we are talking about integration. That does change a lot of it. A lot of it is the change in the business model. Who do I buy my optical chiplet from and place it with whose networking chiplet or CPU chiplet or whoever to build these devices? And then how do I have some level of commonality that I can manage and build and operate these systems? And I think as things trend over time, we're kind of being driven to this by the economics and by the ability to actually go faster and provide more bandwidth. And so the question will be, how does this model change over time? And I think that's, we don't have all the answers yet. So I think, this is an area where we are going to be looking a lot to the industry to help us understand how can we do this better, especially if we start to integrate more of these components into these devices. How do we manage this? How do we effectively monitor these things? As Stefan was alluding to, using AI and machine learning to monitor some of these things, that's important, but there's still some physical interaction that's required to build these systems. And so how do we mitigate some of that so that, again, we can do this effectively and build out quickly enough? Because you can't sit there and walk in and say, okay, I'm going to build a new data center. I'm going to use all optics, but it's going to take me, 2 to 3 years to do all the connectivity in it for it to actually be fully functional. That's just not an operating model that works. So we have to figure out how to make that change also.
Yeah, Stefan, anything to add on that one? Is that an issue that ADVA struggles with as well?
So I think what Brad just alluded to is certainly something that we consider in our design approach. Where do we need to have manual connections on the front of the equipment so you can mix and match and create different configurations, and how much of that can we hide from the operator that is already integrated? So again, we're trying to disaggregate important building blocks so there's choice. But within these building blocks, ideally you should have just one simple interface where you don't need a skilled PhD trained electrical engineer to put things together, but you can just use the personnel that you have that may not be fully trained in WDM optics design and say, well, just connect these 2 or 3 ports and you're up and running. And then you already put together a multi-terabit system. So I think the simplicity certainly plays a role also in the system design beyond software automations, just some simple mechanics about how many connectors, patch cords, etc. do you need to put something like that together.
All right, and Stefan, I'll keep you on because this one called out you specifically. I don't know how much you'll answer it, but I'll ask it. It relates to your presentation. You showed one of your diagrams, a figure showing about capacity per wave and reach, and then they're just looking for some detail. Are they taking into consideration system and fiber aging margins? And then question about, is the open line system using Raman? And any thoughts on baud rate passband used? I don't know how much of that you can give, but they specifically asked about your slide there, so I'll put it to you.
I saw the question. I will happily do a more detailed follow-up. I believe it was a 150 gigahertz passband, but I need to verify that. And clearly in this trial, we did not build in any system margins. We were just saying how much is possible here and now. So when you want to make a commercial offering, you'd have to account for that system margin. And yes, the line system does have Raman amplification also in there.
Okay, great. Yeah, and for you and for the other people that question, if we don't get to it or if you of the presenters want to provide more detail, you can follow up afterwards. Another question came in for Brad. Where did it go? Yeah, it was interesting to me. This fit rate, why optics fit is higher in the data center. Is it because of the new technology? And the comment, generally, optics has better fit than electronics. So maybe you could provide some clarification there.
Yeah, so fit rate is kind of an interesting number, right? Because it's actually a part count number. And so when we started, as an example, when we started using the Inphi colors, the fit rate was actually pretty high because it was brand new components and new process technologies and everything being developed. So, we saw as the volume increased, the fit rate became very low. And right now the fit rate's actually extremely good, but we've been running that, at volume for 3 years, actually almost coming up on 4 years now. But when we look at, these new technologies, like if I'm going to do a deployment of a new technology, if that link is, if I designed my data center or my machine learning environment or something, and I've designed it based upon a very specific, failure rate that I can tolerate for that, having optics dropped in where copper have an extremely low fit rate straight out of the box, to suddenly switch over to optics, which has a very high fit rate, as a new technology straight out of the box, it kind of makes us go, okay, we have to figure out how to work with that. How do we get, we can't wait for the technology to be running for 2-3 years before we see the fit rate that makes us happy. So how do we, and we being the industry, how do we come out with an ability to say, okay, the fit rate is within this target, and therefore we can do these deployments and build these systems based upon the failure rate that we calculated in designing these systems.
All right, excellent. We are running out of time, and we have another one back-to-back on this. So let me, Stefan, I'll give the last question to you. It may involve some detail, but if you could just give a kind of a summary response, because we do want to close out on time. It does relate to your Spectrum as a service and comments about fault diagnosis in case of failure. And really the point is, how do you identify performance degradation, whether it's from the optical line or the terminal side in this type of a service? Is that something ADVA's looked at? Has it come up?
Yeah, there's definitely on the line side some inline monitoring capabilities that allow us to identify if there's a unusual OSNR degradation that we can detect without having control of the terminal. And of course, new generation terminals with all the digital signal processing capability can also detect whether there is changes in anything really from chromatic dispersion, polarization, mode dispersion, etc. So I think both the user of the Spectrum as a service has in his terminal some capabilities to see changes, but also the person offering Spectrum as a service has, I guess, out-of-band monitoring capabilities that we provide to see whether fiber, OSNR degradation, those type of things are still in keeping with what the settings were at the beginning of the service.
All right, excellent. And that does bring us to the end. We do have some additional questions, but hopefully our panelists can follow up. I want to thank our sponsor, ADVA, and thank you to our panelists. Thank you, Roderick, Stefan, and Brad, for joining. Thanks, of course, to the audience. We're going to take a 15-minute break, and then we will resume at 11:45 Eastern Time, looking at optics and edge. So thank you, everybody, for tuning in.
Thank you.
Thank you, everyone.
Thank you.
Bye.
Bye.
Everyone, please bear with us. We'll be conducting some sound checks. Our session will be starting at 11:45 Eastern.
Hello, testing 1, 2, 3.
Testing 1, 2, 3.
Testing. Can you hear me? Testing 1, 2, 3. Testing 1, 2, 3.
Hello, testing 1, 2, 3.
Thank you, everyone who has just just now joining us, our session will be starting in 3 minutes. Hello, everyone, and welcome back to those who joined our first session. This is the second session of day 2 of the Optical Network and Data Center Connect Digital Symposium. Thank you to our platinum sponsors, ADVA, Infinera, and Huawei, and to our gold sponsors, Acacia, CIG, and Viavi. I have a few reminders for the audience. Please keep in mind that on the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget, as well as other resources made available for download from our sponsors. Towards the end of today's presentation, we'll ask you for your feedback. A survey will pop open on your screen, and this will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Principal Analyst, Sterling Perrin. Sterling?
Thank you, Reagan, and hello, everyone, and welcome back for those of you rejoining for the second session of our day of Optical Network and Data Center Connect, which is part of the NGON and DCI World and LightReading collaboration for this year. Of course, in the absence of the live event that many of us look forward to going to each year. This one focuses on, so if you joined the first one, it was focused on revenue generating opportunities in optics. Some interesting discussion among our panelists and presenters there. And now we've moved on to optics at the service provider edge, which also can involve some discussion about revenue opportunities, of course. So here is the agenda for this session. We are looking at, so the 11:45, optics at the service provider edge. I will be the host and moderator. We will start very shortly with a keynote presentation from Juan Pedro Fernandez. He's the head of core networks with Telefonica, and he is going to give us a good overview of the role of optics and some of the ancillary topics around optics and how Telefonica is using them for their edge strategy. And then we'll move to about a 1 hour-ish panel discussion and audience Q&A format, and we'll be joined by Javier Guerre, who's technical strategy architect and senior leader and advisor and consultant. He's got a long title with Telecom Argentina. He's definitely done the rounds on the speaking circuit, and you may have seen him at NGON as well in past years. Nirlay Kundo is distinguished engineer, technology and strategy with Verizon, and then we'll be joined in the panel with Anuj Malik, who is director, product strategy and management with Acacia. Well, of course, we'll gather up your questions during that. I have some topics prepared, but definitely want to get your input as we did for the previous session. But with that, let me move right to our first keynote, and we will let Juan Pedro take us through the Telefonica view. So I will hand it over for Juan's presentation now.
Hello, this is Juan Pedro Fernández Palacios from Telefónica. This session, I'm pleased to present you the company vision about what is the role of the optics at the service provider edge. And first of all, I would like to address the question of where is the edge when we talk about edge computing and the introduction of new applications such as, for example, gaming or video that are intensively consuming traffic in the network. Hello, this is Juan Pedro Fernández Palacios from Telefónica. This session, I'm pleased to present you the company vision about what is the role of the optics at the service provider edge. And first of all, I would like to address the question of where is the edge when we talk about edge computing and the introduction of new applications such as, for example, gaming or video that are intensively consuming traffic in the network. Where are we thinking these servers or these applications should inject the traffic? Okay, according to our estimations and our analysis taking into account both the latency requirements for the application for edge computing and also the traffic consumption and the required investments, we think the perfect location is the HL2 according to our network architecture. What is the HL2? In Telefonica, we have the IP network is split in 5 hierarchical levels. HL1 is the peering level, the interconnection with other operators. HL2 is the backbone level. We have tens of HL2 routers per country. The HL3 is mainly located in the main cities, and the HL4 and the HL5 are in the metro. The HL5 is not depicted in this picture and is covering the cell-side routers in the mobile access. So the edge, for when we talk about edge computing, we think the edge should be in the HL2. This means most of the traffic pressure coming from these applications, from the edge computing, will impact on both the regional and the metro networks. And according to that, considering that this is impacting the connection between the HL2, HL3, HL4, and HL5, what are the requirements? Because the main requirements that we need to face in the optical network for these applications are in the regional network, the hardware for the interconnection between the HL2 and HL3. We need dedicated optical backbones with a combination of 100, 200, and 400 gig. Of course, now we have to substitute, and we are already doing that almost completely, the substitution of all the non-coherent technologies in We have DCM-free networks in most of the Telefonica countries, in the operations in Telefonica. And so we have this traffic, these demands, 100, 200, 400, and using dynamic restoration in the optical layer. In the optical layer rather than in the electronic layer or the OTN. So we considering that the traffics, all the services are moving to IP, and we are not having the combination of different services that we had in the past with TDM or company or enterprise services. Most of the traffic is pure IP, so we think the perfect combination is IP over WDM and the protection in the optical layer with dynamic restoration implemented in the optical network. In the metro, if we go to the metro optical network, one of the main challenges is the introduction of the evolution towards ring topologies, not from rings to star topologies and mesh topologies, in order to reduce the number of hops in the IP network and minimize the investment in the intermediate routers. And this means we need more wavelengths and more optical spectrum consumption in the metro network. And on the other hand, we have an increased fiber rollout in order to cover new 5G sites. In order to reduce the investment to cover these new 5G sites, we are working on network sharing strategies with other operators so that we can offer wavelength to other operators in our coverage area, and we can consume wavelengths in the other operators' area. Okay. This is helping us a lot and the other operators to optimize the investments in the metro, but could be also be facilitated or automated if we use also SDN in order to provide this, to organize this network sharing. I will talk about that later on. Because the third requirement is the SDN. In order to face with the traffic dynamicity, the protection, and so on, we need optical SDN controllers that could be able to provide information from the network to the applications, for example, applications that are using the information for artificial intelligence, big data, and so on. We can provide in Telefonica, our target, or in our strategy, we are using TAPI as MBI. All the information about the network could be exported over a single and common interface that is TAPI. On the other hand, the SDN architecture is also enabling the optical disaggregation that could also help us to promote or to simplify the agreements for network sharing and also optimize the investment network. Very briefly, going about the SDN and the open optical networks in Telefonica, we are implementing SDN architectures that are based on TAPI as northbound interface and OpenConfig as southbound interface to configure open terminals from third parties. We are actively collaborating in the standardization forum and the ONF on TIP, and currently we are, for example, hosting the OEF interoperability test, combining open line systems and open terminals from different vendors in our labs. In this case, we are also collaborating with China Telecom as consultant operator. We think one of the applications of this optical disaggregation could be the network sharing, so that one operator, the operator B in this picture, can use their own transponders, their own resources for the transmission that are controlled by their own SDN controller, and a second operator, the operator A, is offering optical spectrum services, providing an SLA for protection, restoration, performance management, and so on, and all the information between both SDN controllers could be exchanged through TAPI. In this case, we can have agreements that not only providing specific wavelengths, but optical spectrum ranges that could be managed and configured according to the policies and the routine and the engineering of each operator. So that in this case, we could have a kind of a standard interface and a standard service for implementation. Yes, the final messages would be, okay, first, the edge computing is impact is mainly expected in the regional and the metro networks. This means for channels distances typically below 1,000 kilometers, so that the physical impairments shouldn't be an issue. But only for probably we need optical regeneration for less than 10% of the traffic demands. We keep dynamic provisioning and restoration for 100, 200, and 400 channels. The 400 transmission is expected, a wide use of wide 100 channels is expected in a 10 years time frame, mainly. And third, I think the optical disaggregation could play a very important role in order to optimize the cost in these regional and metro networks where we are expecting this traffic increase. For example, because we could open the door to introduction of optical white boxes, or because we can also promote these network sharing agreements using standard optical spectrum managed services. This network sharing could help us and the other operators to optimize the network sharing, the fiber deployments for the 5G. Okay, that's all my side. Thank you very much. Bye.
Hey, Sterling, I think you need to.
Yep. Sorry. Yeah, that's always the mistake. Jeff Bezos did it at the congressional hearing, so I'm in not so bad company. Sorry about that. Yeah, so thank you to Juan for that keynote. He will not join us for the panel, but we have an esteemed group of panelists we've gathered to talk us through the next 40 minutes or so on some of these topics. I think Juan did a great job of really bringing the role of optics into edge, which it's not always talked about. Edge is always talked about, but not in an optics concept. Great. So our panelists, I'll introduce them each, or I'll let each of you panelists introduce yourselves briefly, and then I'll move into some introductory comments, and then we'll get into the meat of the discussion, and then at the end of that, we'll have time for Q&A from the audience. So I'll just go down in order as we see them on the slide. Javier Guerra, Technical Strategy Architect with Telecom Argentina. Hello, Javier. Welcome to this event, and if you want to just give a few introductory comments and introduce yourself for the audience.
Hello, Sterling. Thank you. First of all, thank you for the invitation. My pleasure to be in this panel. Okay, I'm Javier Guerra. I have been in the CSP and ICT industry for more than 20 years, working in technology, strategy, architecture, design, planning, and operation of network and services. Okay, I hold a MSc degree in computer engineering from the Catholic University of Santiago del Estero in Argentina, and a master's degree in network and communication system from the Polytechnic University of Madrid. Currently, I work for Telecom Argentina. And also work in the past for Cablevision Argentina, Verizon, and Chastel Spain, now part of Orange, among others. Thank you again for the invitation.
All right, thank you. Look forward to your comments in a bit. Nirlay, just a brief introduction of yourself, your role within Verizon.
Nirlay Kundu, I'm an individual contributor to technology, strategy, HQ planning group. So deal with all sorts of network planning related to 5G, Mac. Thank you.
Okay, and last but not least, Anuj with Acacia.
Thanks, Sterling. Hello, everyone. Myself is Anuj Malik. I am part of the product management team at Acacia Communications and mainly responsible for product strategy and global business development. I think before going into I think I should talk a few minutes about Acacia Communication because I think some of you may not know about the Acacia Communications. So just want to give a brief overview about that. So Acacia is a leader in coherent optical interconnect, and we have a history of over 10 years in delivering the coherent modules to its customers with improvement in power, performance, and cost. Acacia started its journey by building the coherent modules with the silicon photonic technology, mainly for the long-haul market segments. And today we are serving market segments like in optical transport domain from metro to long-haul to subsea. And today only we have announced our coherent pluggable 100 gig capacity in a QSFP-DD form factor, mainly for edge and access market also. Thanks, Tom.
All right, excellent. Yes, thank you. Welcome, and let's get right into it. I've got a few comments to hopefully set the stage, the edge context within optics, and then we'll get into discussion. But all things start with a definition. I think defining edge computing is still a worthwhile exercise. We'll do that with our panelists in a moment. Juan from Telefonica also gave some introductory a definition as well. So I won't belabor this one, but the concept of placing high-performance compute, storage, and network resources as close to the end users and devices as possible, with a number of benefits of doing so, including lowering cost of data transport, decreasing latency, which is a big focus for edge, certainly as we talk about 5G, and increased locality, which has some benefits of its own. Just a couple points I'll make here, and we can discuss and debate if we'd like, but edge is not a location, but a thing. And we saw from Juan's presentation and talking about edge, it's sort of where it is in the network, and distances become quite a important concept within edge. The edge location can vary depending on use cases, so we could talk a bit about that. A point I make, others may disagree, but I like to use the term edge computing and not so much MEC, which is, in my view, the ETSI-defined kind of iteration of edge compute. So I tend to use the concept edge computing generally, and then if I'm talking about the ETSI initiative specifically, to refer to MEC, but not everybody does it that way. Importance of edge. We did a survey of, actually it was a combined survey of network operators and a few enterprises as well mixed in. We published this last year in August, so about a year ago. And among the many questions on the edge we asked was the importance of edge computing for your business. And the point and why I show this slide is 80% at this time, which was still early stage for edge, reported that it's at least important for their business going forward. Edge is at least important, 80%, 60% saying it's important, and full 20% saying at this point critical. Business can't succeed without it. So even at this early stage, I think enterprises and telecom operators globally understand the importance of edge, even as we're still trying to define it and work out use cases. My last slide before we jump into the topics, this was from the same survey. Again, it breaks out the operators versus the enterprises in this case. But we asked the leading use cases and business drivers for edge compute. And we did see, so first of all, if we're looking at just the network operator respondents to the survey, we do see overwhelmingly that the operators link edge with their 5G plans. We called out 5G specifically, and you can see 67% of them saying 5G is the leading use case for edge compute. But even the other ones that came to the top, second and third, the ultra reliable and the IoT applications are all, also very much related to 5G. So for telecom operators, edge and 5G are tightly linked. Although they're not synonymous, there's certainly our data suggests that it's not a crazy concept to talk about those almost interchangeably. For enterprises, it's a bit different. AI driving the enterprise, at least this group that we listed there. Again, it was a small sampling of enterprises, but it was interesting that what's driving their use cases is different from the telecom operators that we interviewed. With that, let me just jump right in to the discussion. So we've got a set of topics here. We also have a couple slides, not many, but in some cases it's good to show some content. This one actually does have a bit of slide content as well. So let me start. How do you define the edge? I don't think we need to spend a tremendous amount of time on this one, but just to sort of level set the group. Javier, I'll let you kick this one off, and then Nirlay, as the other operator, I'll let you chime in as well. And Javier, I know you have a slide, so I'll put it up there for you. But yeah, go ahead, Javier.
Okay. No, I think there is not a strict conceptual definition about what the edge is exactly. Okay, but there is some consensus that below the 20 milliseconds RTT, we are in the edge environment. Okay. However, if you see, you can see some press release or announcement from some CSPs doing agreement with hyperscales or these kind of things, and they are talking between 20 to 50 milliseconds as part of the edge, which is consistent with what Juan Pedro mentioned in the previous slide. That is the domain of the metro and the regional cloud or hierarchies in our network, and it's something that was in the slide that we are not being able to see right now. Okay, so I would say that this definition has to evolve, because at the end, what is the edge and what we are trying to say with edge is very related with the use case and the LSA that this use case is requiring to us. Okay.
Okay, excellent. And we'll jump into the use cases in a moment. It's a good segue. Before I do that, Nirlay, any other, from Verizon's perspective, from your perspective, anything you'd like to add into how edge is being defined?
The concept, the edge, is where the assets need to be optimized and associated data to be analyzed by the enterprise applications side, right? So this results in continual demands on machines and other edge devices to the applications. So this emphasis on the communication with enterprise and other high-level applications, it's partially the use of the term network edge, since top-down perspective from the enterprise level results in machines appearing at the outer edge. So I'll go a little bit more on where the edge is. So you've heard the terms like deep edge or far edge, where you have tens and thousands of sites, maybe the RAN. And there are different characteristics of these sites. For example, the RAN side, if you split the RAN between CU and the DU, and the edge, the far edge can be any of these. So these sites are, very, extremely compact deployment, maybe unreliable, that have consumer-grade climate control. Moving farther away from the eyeballs, further away from the users, you have the next generation central offices. These are thousands of sites. So those sites would be, NEPS, NEPS-L3 operation compliant. So, and there's limited space, but mainly they will be filled with legacy telco systems. For example, the RNC, the BSC, will be housed there. And then you have the data center, tens of sites of tens of numbers of data centers, small and scalable. And so, full depth deployment and, the scalability of infrastructure is very important. These are kinds of different types of edge as you can progress from the end user to the central data center.
Okay, thank you. We'll dig into more details in those in a bit. And actually, before I move on to the next topic, I just want one point I would make. I mentioned edge is often talked about in terms of distance. Of course, the other metric is latency. Distance and latency are very tightly sort of opposite ends of or two sides of the same coin. Distance determines latency affects what you can have for distance. So let me move to really what is one of the big topics. Nirlay, maybe start with you, and then Anuj, I'll bring you in second on this one. But the primary use cases that are driving edge across the spectrum of options, enterprise, consumer, however you want to slice it. Give some views on that, and then we'll actually let each of the panelists comment on this one.
Sure. So all edge computing has the need to improve digital business interactions, creating more business moments and opportunities through these interactions. So IoT describes a trend of a growing number of things being connected digitally. Yeah. So this is a business approach to managing asset costs, assets in new ways that require a distributed computing topology. Right? So all IoT use cases do not require edge computing, but edge computing increases the possibilities and the use cases of IoT significantly. Right? So whenever more real-time processing is critical, when more data is quantity, or when it's important to ensure continued operation during network downtime. So it's the interaction between the people, businesses, and things that will define the edge computing use cases. For example, between things and businesses, and examples of those are smart meters, software provisioning, business control loops. Between things and things, examples would be industrial automation, autonomous cars. Between things and people, like hands-free surgery, AR, VR, intelligent assistant. And then between people and businesses, like streaming video, health monitors, commerce, and between people and people, we are doing this VR, MR, the conference room, the multiplayer gaming, and between businesses and business transaction processing, compliance monitoring, etc. So some of these interactions are one way, right, in terms of data. For examples include a person using a voice to turn off the lights, or cameras streaming videos to the business, or content provider person. But others are two-way and interactive. So two-way interactive examples would include an immersive experience or automation tied to these business activities. Right? So yeah, that's probably the point I want to make is kind of an interaction between people, things, and businesses that will bring up all these use cases. Yeah.
Okay, great. Let's Anuj, let's bring you into the conversation here again on use cases from I guess a supplier's point of view. What you're seeing with your customers and their customers in terms of primary use cases for edge.
Yeah, like as Nile pointed out, and also Juan Pedro mentioned in the presentations, there are the new applications like either autonomous vehicles or IoT, or I would say gaming. They are driving a lot data towards the edge of the network, and we are seeing the data is moving close to the user, right? So what is happening to take care of all these requirements and the new bandwidth requirements that are coming towards the edge of the network? Each industry, whether it's a wireline or a wireless industry, is coming up with new architectures and technologies. For example, if we talk about the cable access networks, you can see the fiber deep architecture is coming in, and if you talk into wireless, then 5G is now coming up and changing the architectures. From the perspective of customers and the optics standpoint of view, we are seeing a ecosystem is being building up, and we are seeing multiple vendors are building the access platforms, mainly for the converged access platforms, mainly for all the access applications to cater these high bandwidth demands, are bringing up these platforms with high data rate optics. So from that perspective, this is my view on that. Thanks.
Okay, and thank you. Javier, anything to add from what you're seeing, Telecom Argentina, your own perspective on use cases. Have we covered them all, or any other things to add?
Just to complement, I agree with what Nilay and Anu mentioned. But what I think, and that is a personal opinion, okay, the main use cases in the short term will be in the B2B or B2B2C market, okay. We can discuss the verticals, okay, and in fact, obviously the COVID-19 pandemic also can change that, okay. For example, what is related to the medical care or these kind of things probably will have some impact in the use case. But at the very beginning, we are seeing the use cases very focused in the B2B, B2B2C market. However, the volume, the scale, the massiveness of the business opportunity will very dependent, and again, mainly with this crisis that we are living today and the new normality, will be very dependent of each region, country, local macroeconomy, competency, and so on. I mean, we still have to see what will be the economical impact of this crisis in the different regions. Okay, IMF and World Bank are talking about huge GDP impacts for this year, and probably the first Q or the first, second Q of next year. So just to summarize, I agree with the definition from both of the co-panelists, okay? But to summarize, what at least in my personal opinion is that the use cases will be in the B2B2C market. In B2C directly, we are not seeing that. Okay, I'm not seeing it in the short term. In fact, you can have another issues, like, for example, network neutrality and these kind of things in order to give or to do things, to assure some kind of SLA for some consumers. So that is just to summarize, I mean.
Mm-hmm. Question that I guess for you, Javier, or Nirlay, or Anuj, whoever would want to weigh in. But the Telefonica presentation, he spent a fair amount of time talking about this concept of network sharing of wavelengths as something that at least Telefonica is interested in. And I'm wondering, for edge use cases, do any of the to any of you see that as something that is of interest beyond Telefonica? Is that a viable type of use case for edge? Javier, you were just speaking, so maybe I'll give it to you first. Unless you don't want to comment, that's fine. And then maybe I'll pass to Anuj as the optics guy. Javier, are you with us?
Yeah, sorry, again?
Oh. I just lost you there. I was asking about the Telefonica mentioned the concept of shared network with wavelengths as an edge use cases, and I'm wondering if that's something that resonates with you or not, or is that more something that Telefonica is just pursuing on their own?
No. I think what Juan Pedro has presented is something that the industry is discussing. I mean, it's very related with the ONF, OAF, and right now also the Telecom Infra project is doing. So I think it's a very valuable scenario. Okay, and I think one of the main points related to the edge is the footprint. So everything that can allow you or can enable you to share the network and your footprint will be very valuable. Okay, it will depend of every CSP or how they want to do this agreement on or who with they will do this agreement. But for sure, we think this scenario will be more common. I mean, he talked about, for example, this example between optical, I mean, the transponder from operator A and the optical system. I mean, all the optical cloud, the optical gear coming from operator B, and in this case, be able to reach places that maybe at the very beginning you don't have footprint. And that is one of the advantage of the CSP over the, for example, the hyperscale. So I think it's a very valuable scenario, and the industry is going in this direction. I think it's really valuable.
Okay, Anuj, if you want to comment on the wavelength sharing, network sharing with this wavelength concept as an optics guy, any thoughts on it? Something that resonates?
Yeah, I think from an optical layer standpoint of view, I think this should be more abstracted in terms of like software and how you can do that and how you can partition your network among the different customers, because yeah, I think you can do that, and we are seeing that from multiple customers. They are taking a part towards that. The only concern that we are seeing is like, how do you maintain the security and all that stuff? Like if you can deliver that from that perspective, then definitely it's an option going forward. Yeah.
All right, excellent. Let's move to the next topic in the interest of time. What are the primary network requirements for use cases? I'll let the operators weigh in on this. And I think, Javier, you have a slide to lend, so I'll let you start. And then Nirlay, I'll let you comment after Javier. But yeah, how does, so we talk about use cases. How does that impact the network? And to the degree we could talk about optics, let's do that.
Well, we have already mentioned something. Okay, when we define the edge, I mean, there can be. I mean, also there are not a conceptual agreement about the definition of the edge. You can define the edge based on the latency and distance, based on the hierarchy on your network, based on the asset that you will deploy in the edge, based in many things. But at the end, I think that one of the we're talking about the SLA. Let's say that we have in the edge we have a really stringent requirement for latency. Okay, probably the storage will be much lower there. Okay, and you will need to do some kind of processing and doing something, for example, for including artificial intelligence, for example, for industrial control, or what we will be talking about medical care or these kind of things. Okay, but at the end, the big data and the analytic and the offline processing will be in the central cloud. Okay, so let's say that we can have as two axes or three axes. I mean, going in different directions. I mean, you start with the very low latency in the edge. And this latency, I mean, increasing as you move to the central locations, and in the opposite way, you will have, I mean, some scale for storage. Let's say terabytes. I mean, in the cloud, in the central cloud, going to gigabytes or something like that in the storage. It's something to, I mean, don't take this value as, I mean, as exactly values, as absolute values. It's just a reference. It's just a relative values, okay? And at the same time, you have the same with the traffic, okay? And trying to answer one of the QA on the question that say if from the resiliency point of view, if the edge makes sense to have the edge, because you can be disconnected from the network and still have your use case up and running. That is true. That is true. But I mean, it's very difficult right now to talk about in general terms. Okay, we should analyze use case by use case. But in many use cases, probably it's possible that you can continue running in the edge and continue running your use case and and accomplish or being able to give to your customer the SLA that they sign, okay, and you are completely disconnected for a while from the network, okay. So I'm from this is from the SLA and from the network point of view. Well, it's very related with this value that I mentioned. Okay, we can talk maybe with for the reason I think the server related to 5G what the operator has have answered. I mean, in 5G you decrease considerably the latency and the delay in the radio part. Okay, so you can also, I mean, for me it's not mandatory 5G, but it's true that the 5G will empower a lot. I mean, the use cases that you can have in the edge. So maybe you are below between 2, 5. It depends of the technology. 2, 5, 10 milliseconds in the access, and you can have a couple of 10 of milliseconds in the metro, and maybe up to 50 milliseconds in the regional, and up to wherever you want. From the centralized cloud.
Okay, good. Let me, before we move on, let me let Nirlay, as the other operator participant, weigh in on, for the network requirements. How do the use cases translate to requirements? It seems like we're kind of honing in on a couple big metrics, but wanted to let you give your view, Nirlay.
Sure. So, redundancy is a key differentiator. No one will argue about that for the new 5G services, and your frontal transport network needs. So 5G deployment models introduce new optical requirements. For example, more precise RAN, compact carrier-grade Ethernet, time-sensitive networking, right? That converges the transport of all traffic on common infrastructure. So converged transport of all traffic streams over converged aggregation. Right? So fast equipment deployment and service automation with zero-touch provisioning. Right? So as reduced into cell sites, RAN sites, right? So the network connectivity evolved from uplink, downlink, like 1/10 gig to 10 to support this, the resulting cell site traffic. The network needs to reliably agree /400 gig connectivity. So you also need scalable, spectrally efficient 100 gig and 400 gig connectivity to connect 5G-enabled edge data centers, right? So operators need flexibility to deploy wavelength switching through the aggregation network, even where space is at a premium, such as the colo sites, right? So operators, we need to support for dynamic networking for different band optical frequencies, right? So we need a high number of channels per fiber, which maximizes the fiber utilization. We need the equipment that would work throughout our network to get and scale from the core optical network, right? So we need to scale the core network with optical portfolio because we need to use facilities we rely for the metro and the regional networks. So we need technology to automate capacity and spectrum utilization over any distance. We need to automatically adapt to the changing technologies. So the routing software automatically adapts to support longer routes for active and restoration paths, right? So the networks, we need to provide high performance and assured optical connectivity for the cell sites, the edge data centers, and the exchange. So we need to streamline the delivery of optical connectivity to internal customers, including the organization that's slicing, or give internal customers the tools they need to request optical connectivity and visualize the SLAs for connectivity services. And very importantly, security. We need a secure optical network, right? So as 5G begins, confidential data is generated and transmitted across the network. It's becoming increasingly lucrative. So we need to implement cryptographic encryption, data at rest, data in motion. So we need a common set of equipment and tools throughout the network. So this helps to reduce the CapEx and OpEx while making the organization safe to deploying 5G. So these are some of the key points I've noted for the requirements from the operator's perspective.
All right, thank you. Yeah, and nearly speaking on the resilience front. Yep. Oh, go ahead. Somebody was going to
what Nilan say. For some of the reason that Nilan described is became even more interesting the use case that Telefonica has presented us. I mean, related to how to share the network, mainly what he described related to the fiber footprint and these kind of things. Okay, and at the end the disaggregation. Okay, just a quick comment.
Okay, good. Yeah, and we have a question, a topic on disaggregation in a moment. So hold that thought. Before we get to that one, I want to bring in Anuj. Of course, the focus, we really want to focus on the role of optical. And here specifically looking at the role of coherent optics, it is one of the big trends. You mentioned, Anuj, that Acacia has an announcement around this today, which is interesting. So, as we see coherent moving down closer to the users over time, the edge becomes a potential battleground versus direct detect. Certainly, when we talked about the requirements, capacity, coherent would address potentially as well resiliency. The latency, the more you think about it, it tends to be where the compute and storage is. It's not maybe as much a network issue, but certainly optics to a big degree is going to address capacity, resiliency. With that, let me let you weigh in, and I know you have a slide as well, but the thoughts on why coherent will move into the edge versus direct.
Okay. Yeah, I think it's a great question, and it's a very important one too, right? So before talking about the role of coherent into the edge and access networks, I will just first talk about what are the benefits of the coherent technology and why the coherent technology makes sense for us, right? Like for the networks. So if you look into the benefits of coherent technology, one of the key benefits of coherent technology is the operational simplicity, right? Coherent pluggables provides the ease of use to the customers, to the operators, right? But also the coherent technology is also what it is doing, it works on any fiber type. It works on any chromatic dispersions, right? It is not sensitive to back reflections. Like if you have old fiber types and you have fibers with a high PMD, the coherent technology simply seamlessly work on those. So all in all, we can say that the coherent technology leads to very simpler deployments for your networks, right? Another key point and another key advantage of coherent technology is the scalability, right? It makes your network more scalable, and I would say you will have an upgrade path and you can make your network really future-proof. If you look at the coherent pluggables today, either you talk about QSFP-DD form factor or a CFP2 form factors, today you can deploy in any capacity capacities, 100 gig, 200 gig, and 400 gig. So if the bandwidth is like today, you can move to 100 gig, migrate to 100 gig, but in future, if the bandwidth demands grows, you can always do it by like you can upgrade it to 200 gig and 400 gig. So there is a path of upgrade. And the most important benefit of the coherent technology in the era where the bandwidth is growing so much in the network is the better TCO. Like as the bandwidth grows, the coherent technologies provides like less dollar per gigabit, right? It takes less power consumption as compared to and also it takes less footprint also. So overall, the TCO is very less with coherent technology. For example, if you talk about 100 gig coherent pluggable, it is much cheaper and it takes less power and less space than 10 cross 10 like optics that are available today in the market. So now if you look these benefits in terms of the access networks, then let's talk about those. Like, and if you look into the access networks, I will just on a very high level, I can categorize the deployments into two key categories, right? One is like point-to-point deployments and another is like DWDM deployments. In the point-to-point deployment, right, with the coherent technology as it is working in a 1550 like nanometer window, which is a low loss window, you can do like 100, 120 kilometer type of reaches, unamplified links, right? Like just point to point. You plug in the optics at point A to point B, you can easily get 100, 120 kilometers, right? So the performance is good. And also it can work, as I mentioned earlier, on any fiber types. Like, let's say if you have deployed leaf fiber or two-way fibers in the 90s or early 2000, where the direct technology won't work, coherent technology will work very easily on those fibers, right? So operationally, it's very simpler. And also, right, like as I mentioned, we have launched the 100 gig QSFP-DD today for the edge and access market. You can design your platform with the QSFP-DD slots, and today you can put that. But in future, as the bandwidth demand grows, you can always upgrade to 400 gig optics in the same slot, right? So you are taking the same footprint, like a little bit more power, but in the same footprint, you can scale your capacities to like 400 gig. Another key advantage, another key application I was talking about is like if you talk in terms of DWDM application. So in a DWDM application in access network, mostly operators are deploying 10 gig wavelengths. So here, as the bandwidth grows, the coherent once again provides a better TCO because, of course, this coherent today, the 100 gig optics, as I mentioned earlier, is cheaper than 10 cross 10 gig optics. Then also you have a path to upgrade, and also it takes less power, less footprint, and also in the same fiber infrastructure, you are getting a 10x more capacity, as Nirle was mentioned in his points that fiber infrastructure is very important, right? So we have to make sure that you have a path and you can upgrade with a high capacity. Although at the access, we are reaching at a point where bandwidth demands are increasing. So now if you move your 10 gig DWDM to 100 gig DWDM, you are not only reducing the overall total cost of ownership, but also you are providing the 10x capacity also, right? So in the chart I'm showing over here, I'm not sure whether you are able to see this chart. You can, on the right hand side, we are showing you the coherent technology, how the volume, the price, the cost basically, and the power of the coherent technology is going down year over year, right? So with all the continuous advancements that are happening in the coherent technology, so all these advancements, when coupled with all these benefits, are leading to the deployment of coherent technologies towards the edge of the networks and pushing the coherent technology towards the edge of the network. And we really believe that coherent is right now ready for the prime time in edge and access networks. Thanks.
Okay, excellent. Why don't we let's move to the next question. Open and disaggregated networks in the edge. Why don't I do this? Javier, I'll let you start, and then Anuj, I'll bring you back to really drill down. I know Acacia has been very active in open and disaggregated networks, but I think Javier will probably give more of a big picture, and then we'll do the drill down. So just open and disaggregated networks specific to edge. A big big driver or a big enabler for edge, or how do you see it in that context, Javier?
Well, I think disaggregation is always a big topic. In this case, let me split, and maybe Anu can help me afterward, in two parts. One is what is the edge location itself, okay, with their ad set and the services and use cases that we need to offer there. Another other thing is the transport or the transmission from the optical or even IP point of view. It doesn't matter exactly, but in this case we are talking about optic. Okay, so in both cases, in both worlds, for me is very important, the disaggregation. And I have to come back again to the Juan Pedro presentation, okay, because it's in this in this path, okay. Disaggregation always promises accelerating innovation, increases agility, shorten innovation cycle, faster TTM for new service or product, and at the end, as you facilitate or make easier the entrance to new players, okay. Even the TCO can be lower in the medium term, okay. But as an obvious conclusion, when you disaggregate, you have to reintegrate, and this is a non-trivial task. The problem that or the issue that we have today in our industry is that, and for the edge is exactly the same, is that we have we have a huge fragmentation of initiatives. Okay, we have in the edge and also in the optical space, we have many initiatives. Okay. So answer your question, for me, disaggregation is always important, has a lot of opportunity, has a lot of advantage. The point is that you have the challenge of the reintegration, and the challenge of the reintegration can be overcome with interoperability, and at the end, this interoperability comes from the consensus. And if you have fragmentation, this consensus is much harder to reach, you know. So in the edge, it's happening exactly the same that is happening in other aspects of the technology. Okay, I don't know if Anu want to complement, but in optical it's the same. We have the initiative from ONF, OEF, telecom infra project. They are trying to sync in some way. Okay, you have open ROADM on the other side. So, disaggregation is always good. The problem is the fragmentation and the lack of consensus that impact in the reintegration. And let me finish because I know that we have not too much time. It's I include here a conclusion that says something like initiative proliferation from SDOs, open source, or others implies some overlapping and sometimes misalignment. This implies that vendor components are deployed following different initiatives for own definition, because the landscape is not clear. And this implies interoperability impact, lack of interoperability, and this increases the integration effort, and we have higher time to test component, and at the end what we have is higher TCO and TTM. Longer time to deploy new service and increase and increase the vendor lock-in. So we are in the opposite side what we try to reach.
Yeah, good points all. Let me bring in Anuj. If you'd like to start with the fragmentation issue with respect to disaggregation in optics, do you see it as fragmented, or do you see more consensus, particular in optics, as is its role overall in disaggregation? And then I have another question for you.
I would say not a fragmentation. I would say I think we are moving very well in terms of optics for open and disaggregated networks, and Acacia being a strong supporter and a believer of open networks and also the disaggregated networks, and we believe pluggability is one of the way of achieve that, and we are the leader in pluggable coherent optics, and that is what we started. We want to make really optics very, I would say, very open, and it is adopted by the operators, and keeping in mind the ease of use. Another thing from the, I would say, on a disaggregated network, I would like to say that we are seeing a lot of standardization and work is happening, and multi-vendor requirements are coming up in metro networks, right? And we are seeing very similar trends in access networks also. If you look at the initiative by Cable Labs for cable access architecture, what they are doing, they are currently standardizing on the coherent optics for the cable access networks, right? And we are also seeing the standardization is happening in IEEE also. IEEE is now having a standard, is now working on a standard for access links up to 80 kilometers, right? So we are having a standardizations happening in optics also. So we are moving towards that path, and currently we are fully supportive of that, and we are having a product and in our portfolio supporting all these standards, and we are participating in standards, and we are one of the lead vendors to I would say to go ahead with the open and disaggregated networks.
Yeah, I would say certainly from what we see, TIP is doing a good job at really has found it's a home for itself in optics, and really driving a consensus. So I would agree. I would put them as one of the success stories around that. You sort of addressed it. But I just want to make it I guess, more explicit. So when you talk about this coherent edge product that's been announced, and as certainly fits into the edge applications, what is the connection of that to disaggregated and open networks? That's announcement specifically. To what degree does it fit this topic?
So first of all, as I mentioned, of course, it's a pluggable, right? So I would say once again, it's a pluggable. So it can be, it's not like you are really logged in and you have a pluggability. So that is a path towards openness and disaggregated networks. And regarding, we are currently, as I mentioned, multiple standards are coming up with access, and we are a supporter of that. And currently we have, if you look at that, we have a OFAC which is supported by Acacia, and Acacia is the originator of that, and we are doing in Open ROADM and others. So we are participating in all these standards, and all these as the standards are getting firmed and released, we are putting those standards in our coherent pluggables for this access market also, of course. And today we have the coherent pluggables supporting the Cable Labs specifications, and also the IEEE, as I mentioned, 80 kilometers. So it is very much in line with our product portfolio and our strategy, what we are planning to do in open and disaggregated networks.
All right, excellent. I know we're coming to the end. We had one more topic, but I'm going to skip it, although it was interesting, and go to the audience Q&A just to make sure we get questions in. If you do have questions, now is definitely the time to ask them. But we do have a couple in already. Nirlay, I'll start with you, if you're back with us. Hopefully you are. There was a question that came in on what is the difference between local breakout and MEC, or how does local breakout play a role in MEC? So I guess kind of defining the term and concept of local breakout and bringing it back to multi-axis edge compute. Give it a shot. Yeah, I'm not I'm not getting audio from you, Nirlay, if you can hear me. Are you muted?
Okay, maybe now?
Yes.
Okay.
Although there's some echo.
I don't know what. Okay. Let me just.
In the meantime, I think we're losing you. I'm going to have to go to another question because I'm not sure if you're going to come back with us. I don't want to waste too much time. Question came in on, I guess it's a Nuge. We'll move on to you. We see 400ZR has been standardized. Is it commercially available now? Example from Acacia, to the degree you want to answer that. What about the 400ZR Plus? And just thoughts on that. But good question, certainly relevant for the edge. Anuj?
Yeah, definitely. So so for 400ZR, I think it's a public information. We are sampling it with our customers right now, and we have started shipping our first samples months back in February, right? And it is running in multiple customers' labs right now, and we are testing that module, right? And it is planned to be released by end of this year, like the pilot. Regarding the 400ZR Plus, that's a very good question. So as I mentioned earlier, right, Infinera, we are seeing multiple vendors talking about all these OpenZR Plus and Acacia. What they have done, we have done a new MSA called OpenZR Plus, mainly to address the ZR Plus for 400 gig pluggables and also for the multi-vendor interoperability, right? So we have done this open ZR Plus MSA in the month of May, and currently we are working with other vendors who are bringing them as a part of that MSA, and we are planning to have this OpenZR Plus interoperability modules also with multiple vendors. And the plan of these 400ZR Plus, or you call it a OpenZR Plus modules, they will be available at the same time. Currently we are sampling right now, and they will be available at the same time for the pilot deployments by end of this year.
Okay, yeah, definitely looking forward to that. It was one of the things I wanted to follow up on at the OFC show this year that sort of happened, but didn't. So definitely one of the big trends of 2020. Let me try to bring back Nirlay again on the question of local breakouts. Nirlay, you've reconfigured.
Sure.
Are you back?
Can you?
Perfect. Yes,
Can you hear me now?
very good. Yep, and this may be our final question, but yeah, go ahead.
Yeah, I don't know what was going on, but for local breakouts, so the scenario is like this in US right now. So the mean bandwidth for each macro cell in the US would be around 700 Mbps, right? So as a result, the mobile operators have to add more capacity to the macro cell itself, and the backhaul link between the cell and the packet core and to the EPC, right? So the MEC servers enable content and application to be processed as close as possible to the edge of the network, close to the end user, close to the eyeballs, right? And thereby we have a good quality of experience, right? User experience. And this reduces the traffic that has to be sent over the network. So the MEC server can also be used to break out the local internet traffic at the cellular base station. So the application, the LBO application, right, provides traffic routing functions to recognize and direct traffic that can be broken out immediately or tunnel to the internet peering point, right? So all of the traffic from the local cell towers is routed through the local breakout application, right? And then it decides if the traffic should be backhauled to the EPC or broken out to the internet, right? So traffic for the internet is routed immediately through a firewall to a dedicated internet link. And this traffic is therefore not routed through the EPC. So the backhaul and the EPC load and the capacity requirements are significantly reduced. So with the data that's available, so approximately 80% of the mobile data traffic today is video. You may be surprised, but these 80% it comes from the video, because when you download web pages, right, especially with news and they include embedded video. So that's why this video is significant, right? And as soon as you load the page, the video starts playing, right? And so the mobile, this video traffic, right? It's not limited to the streaming TV or movies, right? But also include many other web searches, right? So out of this mobile data traffic, like let's say 40% of this is encrypted and can be broken out locally. So this means that about 32% of the total mobile data traffic can benefit from the local breakout. And as a result, the backhaul and the EPC, the load is reduced by about 32%, right? So a word of caution, those like significant traffic on a particular cell set can be offloaded but for this local breakout to be viable, in other words, there must be significant amount of general internet traffic or the web searches and YouTube videos, etc., to make this cost, right? And complexity of deploying the MEC, because MEC deployment is costly, right? And so this will make the local breakout application worthwhile if there is significant amount of traffic. But as you know, the good news is for most of the mobile traffic is video, and most of the traffic comes directly from the internet. So that's what I would say from from LBO perspective.
Okay, excellent. With that, I'm afraid we are out of time. I know we do have some other questions, but maybe our panelists can follow up individually after the show. There is a survey up, so if you can take a moment to fill that out before we close. We definitely gather that up. I know we had some technical glitches, so please bear with us. It's a new format for us. But anyway, we appreciate your feedback. With that, I want to thank our three panelists today, as well as thanking Acacia for sponsoring this track for us. And thank you to everyone who tuned in and asked questions. That does conclude this track as well as the day for the Optical Symposium. So thank you, everyone, and enjoy the rest of your day. Goodbye.